EE332. This is my final project, and I chose the Smart Eraser as my final project topic. Here is the introduction of my final project. In this project, I implemented a function to erase the text on a newspaper background following the pen. After erasing all text, it should show the original newspaper. And here is the basic idea of this approach. So we isolate it in 3 parts. So the first part is tracking the pen, and the second part is masking the ink area, and the third part is to replace the ink area. For tracking the pen, in this part, I followed the concept of the number 7 homework. I use the template-based local exhaustive search to locate the position of the pen and to simplify the work. So this time I did not use the mouse to initialize the template for searching, but predefine it based on the first frame of the video. The box position, box size are all manually defined. So this is very crucial since we want to erase the red ink along with the moving of the pen. And here is the code for predefined template. You can see that there is some weird number because I manually defined the box position and box size. And the second picture, the picture is for the template of the pen. This is a screenshot from the video. And the second part is about masking the ink area. So naive approach of removing the ink is to replace the minimum rectangle area which contains the ink with another rectangle area exactly below. However, humans can notice that there are 2 rectangle regions that are identical, which is not good enough. So therefore, I want to use a mask to help me only replace the pixels that contain ink. To do so, I will first find a threshold in HSV space that can distinguish the pixel with ink or not. After binarization, some necessary pixels are still excluded. To optimize the mask, I applied the morphology method. I also noticed that at the bottom region of the image, there are some red, which is not the ink I want to remove, so I ignore them manually. So we can see the picture in the first mask ink area. You can see there is the pen and the target area, and there is some red area below at the bottom of the picture. And at the second picture is the result for I manually ignore the pen and the bottom area. We can see clearly the target area here. And the third picture is I use the morphology process, and this shows like a better result for target area. And the third part is replacing the ink area. So in this part, I have 3 levels. So the first level, it replaces frame by frame. So which means the replace algorithm is repeated again and again for each frame. And the second level is in each frame, the replace process starts from the pen position to the end of the image, which is the last column of the image. And the third level is for each column should be checked if the pixels need to be replaced. So we only need to check if in the mask of ink area, if at the same position the value is non-zero. And here is the results. So I took some screenshot from the result video, and you can see like the first picture is around like 100 frames, and the second picture is around 200 to 300 frames, and the third picture is like the ink area is all gone. But we can still realize there is some red ink like remaining on the background. And for future work, just as I said, so in the result picture, notice there's still some ink remaining on the background. So, and this function is designed for remove all the ink. So it should be improved to remove like all the ink area from the background. And the second work is we can improve function without manually defined. Just like I said, I manually defined the position and the size of the pen, and I manually manually discard the bottom area, which is not the thing I want to remove. So I think it should be improved as automatically erasing the ink in any color. And this is my final project. Thank you for watching.